This lesson is assume that the matrix A and B are row equivalent. Without calculation, list rank A and dimension no A. Then find basis of column A and row A and no A. Now be very careful here. A and B are row equivalent. That means matrix A is the original matrix. Matrix B is the answer to matrix A after row operation. One more time. A and B are row equivalent. That means A is the original matrix. B is the answer to matrix A after row operation. Okay, one more time. Matrix A is the original matrix. Matrix B is the answer to matrix A after row operation. Okay, so number one, matrix B is in echelon form. The last row is all in 0. That means B is the answer or the solution to A after row operation. Okay, so that's what number one says, that B is the answer or solution to matrix A after row operation. Okay, next, 2. There are 2 pivot columns. So here's the first column, I have 1. Here's the second column, I have 2. So I have 1 pivot, I have 2 pivot column. So dimension of column A is 2. 3. There are 2 pivot rows. So here's 1 pivot row, here's second pivot row. One more time. 1 pivot row, second pivot row. Okay, so this is the first pivot row, this is the second pivot row. So therefore the dimension row A is 2. Okay, 4. There are 2 columns without pivot. So here's 1 column, 2 column. There are no pivot here. So therefore dimension no A is 2. 5. Basis of column A is the pivot column. Okay, so here's the pivot column, here's another pivot column. So I have first column and second column has a pivot. So therefore you will take this column, the first and the second column of A, to be the basis. One more time. Basis of column A is the pivot column. So here's first column, second column. These 2 columns has a pivot. So you will go to A, take the first column and the second column to be the basis of column A. So here's first, which is here. Here's the second, which is here. Okay. Next, number 6. Basis of row A is the pivot of row B. Okay, so here is pivot row 1, pivot row 2. So this first row and this second row is the basis of row A. One more time. This is first row pivot. This is the second row pivot. So this first row and this second row will be the basis of row A, which I wrote it here, 1, 0, negative 1, 5, which is this row right here, and 0, negative 2, 5, negative 6, which is this row. Okay, next, number 7. Number 7, to find the basis of no A, row reduce to row echelon form of A. However, if you look carefully here, that only the first row and the second row has a pivot. So therefore we will not include the third row because there's no pivot in the third row. Okay, all right, so one more time, there's a pivot here, there's a pivot here. so we will not include the third row. Okay, but we're not using the B matrix, we are using the A matrix because it is asking no A. Okay, so one more time. In B, we have a pivot here. We have a pivot here. So therefore, we cannot use this last row because there is no pivot here. Okay, so we're only using the first row and the second row. But we're not using B. We are using A to find no A. Okay, so again, pivot 1, pivot 2. The third row, since there's no pivot, we're not using the third row. We're only going to use row 1 and row 2 from A. Why A? Because we're looking for no A. Okay. So now we do row operations or row reduce. Okay. And we need this to be a 0 right here. So opposite of -1, we do +1. So +1 times row 1 plus row 2. So 1 times 1 is 1. Subtract -1, 0. 1 times 1 is -4. -4 plus 2, -2. -1 times 9 is 9. Subtract 4 gives me 5. -1 times -7, which gives me -7. Plus 1 gives me -6. Okay, next we need this -2 to be a 1. So multiply the reciprocal of 2, which is 1/2. However, we want a positive 1, so we need a negative. Okay, because this is a negative, so we need a positive, so we need another negative. So -1/2 times -2 gives me +1. -1/2 times 5 gives me -5/2. -1/2 times -6 gives me +3. Okay, next we have a pivot here, so this 4 has to be a 0. Okay, we have a pivot here, so this 4 has to be a 0. So opposite of -4, +4. So 4 times row 2 plus row 1. So 4 times 1 is 4. Subtract 4 gives me this 0. 4 times -5 gives me -20. Divide by 2 gives me -10. Plus 9, -1. 4 times 3 gives me 12. 12 subtract 5. 12 subtract 7 gives me 5. Okay, now we are completely done because we have a pivot here, 0. Pivot here, 0. So now we will list out our term. So x1 plus, so x1 minus 1x3 plus 5x4 and then equals 0. That's what I have here. One more time. x1 minus 1x3 plus 5x4, what I have here, and then solve for the first term. So bring the negative, become positive. Positive 5 becomes negative, so bring it to the other side, the right hand side. So negative becomes positive, positive becomes negative. Do again for the second pivot. So 1x2 minus 5/2x3 plus 3x4, which I have here. Okay, so 1x2 minus 5/2x3 plus 3x4 equals 0. That's what I have here. Solve for the second term. So negative and positive, bring it to the right side. So negative becomes positive, positive becomes negative. Okay, next, this is column 3, this is column 4. So x3, x4, since these two right here already taken from x2, so now they are considered free. One more time, this is x2, this is x3, because they are already taken from term 2, they are considered free. Okay, so one more time, pivot 1 right here, so x1 minus 1x3 plus 5x4. That's right here. Solve for the first term. Here is the second pivot. So x2 minus 5 over 2, x3 plus 3x4, which I have here. Solve for the second term. This right here is x3. This right here is x4. Since x3 and x4 already taken from x2, they are now considered free. Okay? Now separate them by the x's. If there is x1, go to x1. If there's x2, go to x2, and so on. What we have here, I only have x3, x4, x3, x4. So we only have x3, x4, okay? Again, we only have x3, x4, x3, x4. So therefore, we have x3, x4. The first term of x3, okay, it's the first term right here of x3, which is right here, 1. The second term of x3, which is here, 5 over 2. The third term of x3, since it is free, 1. The fourth term of x3, there is none, so 0. For x4, the first term of x4 is negative 5, which I have here. The second term of x4, which is here, negative 3. The third term of x4, there is none, so 0. The fourth term of x4, which is 1, because x4 is free. So these two vectors are the basis of null A. Okay? So be very careful, especially when it says A and B are row equivalent. That means A is the original matrix, B is the solution or the answer to A after row operation. Okay, so be very careful when it says A, B, or row equivalent.